So for our angle bisectors, it says you're going to follow these 3 steps here to construct an angle bisector for examples 1 and 2. An angle bisector is just something that cuts your angle in half. All right, so it's going to half your angle or split it into 2 congruent angles. All right, so step number 1 says you place your compass at A and draw an arc that intersects both sides of the angle and label the intersections C and B. Okay, so I'm going to give that a try here on example 1. So it says I'm going to take my compass, put the pointed end on A, and then your pencil end, it doesn't necessarily matter where it falls, but whenever you draw your arc, it has to cross both of the lines. So kind of like when we're constructing a congruent angle, right? That first arc we draw. Okay, and then it said that the 2 points where it crosses the lines, or the 2 intersection points, to name those points C and B. All right. Okay, step number 2 says you are now going to take your compass and put your pointed end on C and draw an arc. And if you look at figure number 2, it kind of shows you that it's kind of out in this area over here. So you put your pointed end on C and your pencil end just somewhere there towards the middle of your 2 lines, okay? And you draw an arc. So look, something like that. Okay? And then keep your compass at that same width, it says. Flip it around. Now put your pointed end on B and draw the exact same arc. And as long as you didn't change the width of your compass, then those 2 should intersect each other at not just any point, but right in the middle of these 2 lines should be where they're intersecting. Okay? It says on step number 3, that we need to label where those 2 lines or 2 arcs intersected G. And then take your ruler and use it as a straight edge, and you're going to connect that new point G and your original vertex A. So like something like this. Okay? All right, so as long as your compass didn't move too much while you were creating this, it should appear that this line goes right down the middle of what was originally angle A, right? So I should now be able to make a couple of different statements about what we have drawn. Okay, so let's make a few statements here. These are all things that could be asked in questions about what you see in the drawing, okay? So first of all, I should know that the 2 angles it was split into, this one here on the top and this one here on the bottom, are the exact same size, right? So I'm going to call the top one angle CAG. So angle CAG is congruent to the one here on the bottom, BAG. Okay, and since those 2 pieces are congruent, then I should also be able to say that the entire angle, CAB, would be equal to one of these sections multiplied by 2, right? If they're the same size, if I double one of them, it's congruent to the whole angle. So I should be able to say the measure of angle CAB is equal to 2 times the measure of one of those sections. So maybe the top one, the one we called angle CAG. All right, which also means it could have the reverse effect. If I multiplied the big angle by a half or divided it by 2, it should give me one of those pieces, right? So then I could say that the measure of angle BAG, so maybe the small one on the bottom, is equal to 1/2 the measure of the entire angle CAB. All right, so that's just a few different ways they could state what you have drawn here. All right. Okay, We're going to, again, construct another angle bisector there on example 2. So same steps. We start out with our compass, placing your pointed end on A and your pencil end somewhere over here on the line. Doesn't matter where. But whenever you draw your arc, it has to be big enough so that it will cross both lines in your angle. So it's got to come all the way up here. It looks something like this. Okay, so once you've created an arc that crosses both lines, now you have these two intersection points here and here that we'll call B and C. Okay, and then our next step was to put your compass on one of those points and draw an arc out here. So it looks something like this. And then while you have your compass at that same width, do the exact same thing, placing your pointed end at point B. Okay. Now, depending on how wide or narrow you have your compass, where yours are intersecting could be a little bit above or below mine, but it should still be in the middle, as long as you didn't change the size between making the two. All right, so my intersection point's right here, and I'm going to label that G. And then my last step is to take my ruler as a straight edge and draw a line segment from point A through point G. So this ray that we just created, AG, bisects the entire angle, BAC. Or CAB, whichever way you prefer to write it. All right, so I'm going to give these two separate angles names. I'll call the bottom one angle 1, the top one angle 2. So this means that those two angles are congruent. Angle CAG, which is the bottom one, number 1, is congruent to the top angle, BAG, which is angle 2. And then the same information that was said on the top. One of those two segments, doesn't matter which one you want to refer to, maybe the angle 1, CAG, would be congruent or equal to the measure of 2 times, or sorry, of 1/2 the other one, of 1/2 the whole one. 1/2 angle BAC. And then one of those angles could be doubled to be equal to the entire angle. So the measure of the entire angle, BAC, would be equal to 2 times either one of these, 1 or 2. The measure of angle, I'll use BAG this time. All right. Okay, so now that we know what an angle bisector is, what it means, and what it does to our angles, if you'll flip it over onto the back, we've got a couple questions there to answer. So number 3 is a good potential test question that you could see on your test on Monday. It says that the diagram below shows the arcs and segments that were used to construct line MN given point P and line LR. It says MN was constructed to be parallel to LR and pass through P. Okay, so they are telling us that these two lines, LR and MN, are parallel lines. If those are parallel lines, that means we have all of our types of angle pairs, right? Okay, the question says, based on this construction, which statement is not true? So I'm looking for something false. All right, so the first answer choice is that QR, which would be this little segment right here, is equal to PN, this segment here. Should those two be congruent in size? Yes, so this one's true. We know that they would be the same size because of the compass width, right? You wouldn't change the size of your compass when creating those two arcs, so they should be the same size. All right. Next, they say that the measure of angle RQP, so RQP would be this angle here. I'm going to call it angle 1. Okay, so this is angle 1. And angle QPM, so QPM would be this angle here. I'm going to call it angle 2. Okay? It says that those two angles should be equal. What do we think? Should those two angles be congruent? Yes. Why? Because they're what type? Right. So I can say because we had those parallel lines, that let us know that those are alternate interior angles, which we do know are congruent. Okay, so this one was true as well. So it's not F, not G. Okay, H says angle LQP. So angle LQP would be this one here. I'll call it angle 3. Is complementary to angle QPM. So QPM is the one that we numbered angle 2. Are those two angles complementary? No, they're what? Supplementary. So this one would be false. Okay, so that's probably our answer. Next one says angle QPM, which is the one that we named 2, and angle NPQ. That would be this one here, form a linear pair. Well, 2 and 4 do form a linear pair, right? So that one would have been true as well. All right. Okay, we got one more question to look at. Complementary means that they add up to 90 degrees. All right, last question here says that Kendi used a compass and a straight edge to construct the line segment FH. So from F to H, she used those steps that we talked about on the front page to create that line. Okay, and the triangle DEF was already given. Based on this construction, which statement is not necessarily true? So again, we're looking for something that could be false or is false. Okay. All right. So first it says that the segment DE, which would be this entire side here, is equal to side EF. So do we know that for sure? Okay, so this one's looking like a potential answer, right? Okay. Then they say that the measure of angle DGF, this angle here, is 90 degrees. Should that be true? Yes, because it should be perpendicular if it's running vertically and horizontally, right? Same, it would be true for this angle over here. All right, so it's not that one. That one is true because those lines were perpendicular. All right. Next answer choice says that 1/2 of DE, so this line down here, if you were to multiply it by 1/2, it would be equal to this segment here, GE. Yes, that would be true. Okay, so this one is true because FH, yes, definition of bisector. FH bisects DE. Very good. Okay, then the last one says DG, this segment here, is congruent to this segment here, GE. Yes, for the exact same reason that we just mentioned, right? So this one would be true for the same reason. All right, so our answer must be A. All right, so our angle bisector cuts angles into two congruent pieces, okay? And if it's a triangle or something like this, it also tells us that it's going to split the line that it bisects into two congruent pieces as well, right? Okay.